I've never seen this pipe before. Maybe it's got some secret power-ups.
Alright everyone, today I'm going to give you an example of graphical behavior of different function families. So what I mean by different function families, I'm referring to linear functions, exponential functions, quadratic functions, functions of that nature. Today I'm only going to focus on linear functions, and I'm going to talk about just some simple graphical behavior, whether it's increasing, decreasing, or constant, maximum or minimum, curved line, okay? And now that I think about it, I might just touch on different function families so that I can cover all three of these, okay? So let's start. So increasing, decreasing, or constant. So let's say we have a function here. Yes, I know my lines are not straight. Okay, we have a function. I'm just going to do a linear function. Okay, this is a linear graph function equation. No, not equation. It's a linear graph, okay? Now, from this linear graph, what can we tell? Is it increasing, decreasing, or constant? So it is increasing. We can tell right away. Does it have a maximum or minimum? No, it has neither, okay? And I'll give you an example of one that has some. Is it a curve or a line? It's a line. All right? So in case you don't know, I'm sure you do though, I'm going to do increase. A graph that would be decreasing would look something like this. And a graph that is constant is basically a straight line. Okay? That would cover all three of those. Increasing, decreasing, or constant. And a linear graph can be either of the three. Okay? So let's look at a different kind of function family. Well, we can tell that from here to infinity, it's going to be increasing. And then from, change colors, from here to about here is decrease. Whoops. Okay? So it's decreasing all through here. Then it starts to increase at this point. Okay? So a quadratic function increases and decreases, okay? So we got that covered. Let's write that down. Increase and decrease. Maximum or minimum? So in this case, it does have a minimum right here. That's the minimum point of the graph. It's the lowest point. Vice versa. If we had another graph, let's say it looked like this. Then we could say the maximum of this graph would be at the very, very top. So maybe around here. Okay, that would be the maximum point. And just like the other graph, we have areas where it's increasing here. See, it keeps going up, increasing. And then at this point, after it passes the maximum, starts to decrease. So this would be the increase. And then this would be the decrease. Okay? Curve or straight line, as you can tell, it curves. That's the easy part. Okay, so 2 examples, increasing, decreasing. We have constant. We covered a couple of those. What a maximum and a minimum are. Now, different function families will have different graphs, obviously. So the minimums and maximums, you'll be able to look at them there. And curve or line is pretty self-explanatory, okay? So let's just run through a couple of quick examples so we can just say we did. Say we have an absolute value that looks like this. Okay? Well, we know by looking at it, it both decreases and increases. We know that it does have a minimum right here. Oops. That's the minimum point of the entire graph. I'll just write minimum here. And is it a curve or a line? It's a line. Actually, it's lines. But lines. You get it. Okay? So you're going to have a variety of function families. And I have them on the slides already, so you'll be able to look through those. And these are the types of things you'll be looking at, the 3 graphical behaviors of them. Okay? All right. So I hope this video was helpful. See you guys next time. Peace.